Today, we'll be presenting Schimatos, which is a resource that can be used to generate forms from shackle constraints and subsequently update data via Sparkle endpoints. The primary motivation for developing such a tool is to improve the accessibility for viewing and editing data on the semantic web, especially for more naive users. So if we look at current tools that allow us to do these kinds of operations, we have
the Elder API, Metafactory, and many others.
So this is quite widely explored, but we will note that none of these are really hierarchical views. And then on the editing data front, it's a bit more of a question mark. So there's tools like Protege, which can be used primarily for updating ontologies and editing ontologies, but can also be used for creating instances of data. But this does come with the inherent danger that in the process of trying to create a person, such as Tom, you're accidentally going to update the whole class for human instead, which is obviously not ideal. Then there's some similar form editors like Shex Forms, which takes a similar constraint language and generates forms from it. From what we've seen, most of these tools are still in a prototyping phase, but they do appear to be promising. We note that at present, these and other tools that we've found for editing linked data in this way are only available to edit local files as opposed to external triple stores. So what is Schimatos? Well, as we've said, it's a form-based web application. It allows users to update knowledge graphs, and it also allows users to generate and create forms, and in turn generate shackle constraints that correspond to them. Wikidata has a collection of schemas that are used to define the expected structure of several classes. For instance, they have this simple schema for a human. What we've done is taken this Shex constraint and translated it into a shackle file that can then be used in Schimatos. Normally, this process can be done by a tool such as RDF Shape. For our purposes, we've done this manually so that we can add in some additional constraint properties such as a pattern for date of birth. So if we take a look at the shackle constraint language, we know that it's used generally to describe and validate these RDF graphs. And the way that we use this constraint language is to map node shapes to forms and property shapes to fields within these forms. Let's have a look at how we generate these fields from property shapes. The first thing we do is look at the XSD type associated to a particular property shape. If it's a string or a URI, we just provide a text box, booleans, checkboxes, and so on. And for URIs, we actually provide a slightly more customized box where you can select prefixes and then put in the fragment after that. We also look at the validation constraints within that particular property. So in property shapes that have the in constraint, we know that we've got a finite set of options from which the user has to select from, so we generate a drop-down. And we can see that how this maps from the shape. So here we've got the Wikidata human shape. The particular path associated to that is WDT-P21, so that's the gender property. And then the in constraint is telling us that we've got these 6 URIs to actually choose from. And from that, we generate this drop-down. In practice, we also overlay the label on top of these URIs for the benefit of the user, and we'll see this in our demonstration later. Another thing that we do is, based on the patterns or the regular expressions that are used to constrain these properties, we customize the field entries. So for date of birth, if that was described using this regular expression pattern, we know that it's going to be 3 numbers with slashes in between them, so we can actually generate this more customized form field. What we then do for nested shapes is have nested form fields. So here in this example, we've got a place of birth, and then that place of birth, which is a city, has an associated country, and that's in a nested shape structure. So we just take this corresponding structure and put it into this form here. It's also worth discussing how we handle recursive shapes, because the validation is actually a little undefined within the shackle standard, which means there's a few options on how to validate and subsequently a few options on how to generate this form structure. What we choose to do at the moment is, if a nested component has a recursive shape associated to it, for instance, if we are talking about this human here, and they have a father, Sergio Sr., then that Sergio Sr. will also have a human shape associated to it. So this is a recursive structure. And what we do is, if we fill out the name Sergio Sr., and that is an incomplete human within the graph, then we generate a new human form within this field, so that users can continue to fill out these details. There's a few additional things we do, as well as submitting the data that is input by users in this process. We also include the class assertions and the data type annotations automatically. So for instance, when we submitted the human Sergio Sr. in the previous example, we'll also add the triple that Sergio Sr. is a human. Or if we were to add something like an ORCID ID when we submit a data type property, we'll actually be sure to add that data type property associated with that ORCID ID. Because of the fact that shackles inherently designed to validate data, it wouldn't make much sense to have a tool like Schimatos without having some kind of data validation associated with it. The first stage is validation of properties that don't rely on any other data in the knowledge graph. So these are things like the pattern that a string has to follow, or the range that a number has to fall into. Because of the fact that they don't rely on any other data within the graph, we can immediately provide feedback to the users when they try and fill in an entry that this is incorrect, and it will prevent them from entering it into the form and provide a red invalid box. Now what we'll do is run through a quick demonstration of entering data using Schimatos. So this tool can either be downloaded and run locally, or it can be accessed through our website at schematos.github.io. At present, Schimatos allows you to interact with and update any data that is made available through a Sparkle endpoint. And we can specify that in our settings by setting the triple store that we want to access, the location of the shackle files. In this demo, we'll discuss how to update information about an entity called Sergio that's within our data graph, and we'll do that using a human form generated from a shackle constraint. Looking at our UML diagram, we can see that when we search for a particular entity using this string, we'll run this query over our triple store located on an external server to collect the relevant subjects. There are options to fine-tune by whether you want to go label or other variations, but in this case we're just going to go for any object that contains the string Sergio. We've added the labels instead of putting the IRI here, so users can see what is actually going on. We generate on the side here a bit of information about this entity, so that allows us to verify this is the particular entity we want to edit. And now that we've done that, we'll be running a search over our shackle graph. That graph may be located in the same triple store as our data, or it may be located in a different triple store. And then we'll run this query to extract the shackle shape. We'll see that we've actually got two options here. The bottom option has been put in by us as a direct translation from the Shex constraint. There's also another shape here, which appears to have been uploaded by another user. So we're going to use this translation from the Shex. So we can see that in addition to our selection of which shape to use, we can select by severity levels. So severity levels are
within the definition of the shape itself. For each property, if that severity isn't specified, we take it to be a violation level severity. And using those pieces of information, users can select which property fields from the shackle constraint they want. And we're now generating our form. We can see that some of these fields are colored in green. Those are fields which pass the validation criterion. So in the cases of these three, that would indicate that the min count for these property fields is 0. In the case of gender, that has an in property, which means that only these 6 options can be used to satisfy this particular field. So we're going to select the option male, and then we can now come down to date of birth. This date of birth field has been customized based on a pattern constraint provided. So we're just going to input a date here and submit that. And now we'll come down to place of birth. We can see that Schimatos actually provides some options for us here. These options come from existing objects of this place of birth predicate that are in the graph. So one option is Canberra, and because the label for that object is also in the graph, we display the label. There's also this particular entity, but it doesn't have a label within the graph, so we just give the IRI instead. So we're going to select Canberra, and now we've satisfied our place of birth for city. In terms of country, it appears there's no values within the graph yet. So what we're going to do is just manually enter the identifier for Australia, which is WDQ408, and we can submit that. So within the human shape, if you've got mother, father, sibling, or any of those other human entities that satisfy a property field, then this is actually a recursive shape because they must also satisfy the human shape property. And we can see that if we enter this mother field. So we're now going to enter Sergio mother, put that into our form. And now that we've got all this data ready to go to be submitted into our triple store, we can choose to select all this data. We can see that it's now in the triple store. This is another human shape within here. We know no information about this mother as of yet, so it's all empty and users can choose to work with this. So now we're going to go through the process of creating forms in Schimatos, which is the same as creating shackle constraints. We're first going to merge the human shape and the university shape. So first of all, let's go and collect our human shape, and we can select that. And now instead of applying this, I'm now going to search for the university shape. And now that that's loaded, we can select Wikidata University Teacher. And I can see that I've now got these 2 shackles ready to apply. And now what Schimatos is doing is it's actually merging these 2 shapes to create the strictest shape possible. So if there's overlapping property fields, it will take whichever property field is most strict, and otherwise it will just produce the union of all the different properties. This is indeed different to the human shape we had before because we have this employer field, we have university, which weren't present in the previous shape. Suppose that I wanted to also add the ORCID ID for this researcher. What I can now do is manually add this property constraint or this field into the form. So the first thing we're going to do is specify the predicate that will be associated with this property, and that from Wikidata is WDT P496, and that's just going to be a normal path. We'll keep this at a violation level of severity. We're going to specify that they can have at most 1 ORCID ID, and we also want to add another couple of constraints. The first is that we want the name to just be ORCID, and the second thing that I'm going to add is a data type. And within this data type, I'm going to specify TP orchid. Now what I'm doing here is I've actually got a reference to a type store. And a type store is something we've created for Schimatos that creates a property shape constraint for a particular data type. In the case of an orchid ID, that is just going to specify that the orchid ID has to be a string that follows a particular regular expression. So now that I've entered this information, what we can do is submit this, and we can see we've now got this orchid ID field, and it's got the correct structure for an orchid ID. Now that we've done this, we can note that we've got a corresponding shackle file that's been generated from this form. Now that we've been through some examples, let's just have a look at the MVC architecture for the tool. So our model is just the data that is being used to generate our forms and to fill our forms. They come in the form of triple stores with a Sparkle endpoint. They do not have to be located on the same server as Schimatos. In fact, Schimatos can be run locally. And the shackles and the data don't have to be on the same server either. They are just input by the users as a URL. To note, ANU is going to be setting up a shackle store under the domain name shackle.kg. So then whenever we're using the tool, for instance, displaying a form, updating details, doing what we want to do, our controller will query this model to obtain the data, to obtain the shackle constraints, and then generate the form using these mappings, create a form display, and that is then displayed to our end users. Schimatos has ongoing funding as part of a larger government project, which means that in addition to continued maintenance, we also expect to see quite a bit of additional work on the tool. This includes handling multiple types of data sources, such as local files, solid pod files, and in the future, things like RDF star as well as Sparkle star. We also hope to handle logical constraints in the future. We're looking to perform some more formal user trials and publish those results. And we're also looking to update the backend of the tool completely to TypeScript, and we'll most likely do that using a library that we're currently developing called